What's up, team? Here's a video for page 194, numbers 14 and number 18 at the request of a handful of students. So I'm going to work through both of these examples. I'm going to move through a little bit quicker than I did in class and a little bit quicker than the other video, because I'm operating under the assumption that you were paying attention in class and that you've already watched the other video. So I'm going to show all my work, don't get me wrong, but I'm going to move through a little bit quicker. So if you need to pause, rewind, rewatch, do whatever you need to do. All right, let's get right into it. So number 15. This one says, find the orthocenter. We have points A, B, and C. A is at -1, 2. B is at 9, 2. C is at -1, -3. We need to find our three equations of our altitudes. So I've set it up. I need the equation of the line that goes through vertex A and is perpendicular to the opposite side. That's the first thing I'm going to do. Then I'm going to find the equation of the line goes through vertex B and is perpendicular to its opposite side, then the one that goes through vertex C and its opposite side. Three separate equations, all in point slope form. Let's do this. So first, we're talking about side BC. Side BC has a slope. So I'm going to do delta y over delta x. So that ends up being -3 minus 2 over -1 minus 9. -3 minus 2 is -5. -1 minus 9, -10. Negative divided by a negative is a positive. 5 divided by 10 is 1/2. So it's going to be positive 1/2. That's the slope of this side BC. We don't care about that slope directly. We want to know what's perpendicular to that. So I'm going to say perpendicular slope to that is going to be -2. That is the opposite reciprocal of 1/2. Now, that's the slope of this line, and this line has to go through vertex A. Vertex A is at x sub 1 is -1, y sub 1 is 2. Remember, no math to find these, I just copied them down. Now, I'm going to plug these three pieces of information into point slope form. Y minus y1, which is 2, equals our slope times x minus x1. In this case, we are adding. I'm going to go ahead and simplify this right here, right now, because I'm right next to it. So this is going to be a chop-chop situation. I'm going to distribute the -2. Y minus 2 equals -2x minus 2. And then I'm going to add 2 to both sides. So y equals -2x. If I add 2 to the left, I add 2 to the right, this is going to end up canceling out. So in simplest form, the equation of this line is y equals -2x. There's one of our three equations that we need to find. Number 2. Equation of the line goes through vertex B and is perpendicular to AC. So I'm going to do the same thing. AC is the side. The slope of AC is going to be -3 minus 2 over -1 minus -1. -3 minus 2, -5. -1 plus 1 ends up being 0. This is an undefined slope. That means it is perfectly vertical. Perpendicular to that is something that's perfectly horizontal. That's a slope of 0. And we can also tell this if we just flip it upside down, it'd be 0 over -5. So our perpendicular slope in this, perpendicular slope here is 0. Sweet, that's actually going to be kind of nice. It'll be easier to work with when we have a slope of 0. And this has to go through vertex B, which is 9, 2. So our x sub 1 is 9, our y sub 1 is 2. Let's plug it into point slope form. Y minus y1 equals the slope times x minus x1. So now we have y minus 2 equals, well, when we distribute the 0, 0 times x is 0, 0 times that is 0, it just ends up being 0. So the equation of this line, y equals 2. Easy peasy. It's I know that feels a little uncomfortable, but it is what it is. It's actually going to make things way easier for us too. Okay, third one. AB. Find the slope. M equals. So B has a y coordinate of 2. So on top we're going to have 2 minus 2, and on the bottom it's going to be 9 minus -1. 2 minus 2 is 0, 9 minus -1 is 10. This one's going to be the opposite. Currently, this has a slope of 0. When we flip it upside down, the slope of this thing is going to be undefined. And it seems like it's going to be hard to work with, but it's not going to be so bad. Undefined slope is one that's perfectly vertical, so it's in the form of x equals something. It's just always going to have the same x value. So, for instance, if I had here's a Cartesian plane. If I had the slope or the graph of x equals 5, I would just go out to x equals 5, and it would be this line right here. It's the line where x always equals 5, no matter what y equals. So we're going to use this to our advantage. We know we have an undefined slope. It's a perfectly vertical line, and it's going to be in the form of x equals something, just like how this one is. The question is, what is that something? Well, we know that this thing goes through vertex C, and vertex C has a x-coordinate of -1. So the equation of this line is as simple as x equals -1. Now, we have this system of equations that we need to solve. And just by looking at them, something unique is here. We already have an x value. We already have a y value. That's cool. That seems to mean like we're done. It seems like our x-coordinate is -1. Seems like our y-coordinate is -2. Let's check that just to make sure. The way that we're going to check that is we're going to take our third equation, y equals -2x. Y equals -2x. We're going to plug our two coordinates in. -1 for x, +2 for y. If we can make the left side equal the right side with that information, it's a win and we're done already. So y, we said is 2. -2 is still 2. The x-coordinate is -1. -2 times -1 is indeed +2. 2 equals 2. So this is a weird one. Our system of equations we didn't even need to actually solve because the equations of the lines ended up giving it to us. We had a horizontal line here, we had a vertical line here, and that just gave us all the pieces of the puzzle that we need. So the orthocenter for number 15 that we're working with, this is number 15, yes, is -1, 2. Okay, stay tuned. I'm going to do number 18 next. All right, here we go. Number 18, same thing, different numbers. Finding the orthocenter. A is now at the point 8, 10, B is at the point 5, -10, and C is at the origin at 0, 0. So first, find the equation of the line that goes through vertex A and is perpendicular to BC. BC, we need to find your slope. So I'm going to do 0 minus -10 on top, and then 0 minus 5 on the bottom. 0 minus -10 is +10. 0 minus 5 is -5. So we have a slope of -2. The perpendicular slope, so that the opposite reciprocal of -2 is +1/2. Now we know this goes through vertex A, so our x sub 1 is 8. Our y sub 1 is 10. Let's plug in the pieces. Y minus 10 equals 1/2 times x minus 8. And again, I'm going to simplify here. Y minus 10 equals 1/2 x minus 1/2 times 8 is 4. I'm also going to add 10 to both sides. So let's wrap this up. Y equals 1/2 x. -4 plus 10 is 6. There's our first equation. Let's keep plowing forward. Number 2, it's going to go through vertex B and perpendicular to AC. So AC has a slope. Again, I'm going to do 0 minus stuff. So on top, it's going to be 0 minus 10. Oh, that confused me. So then it was -10. We're good. And then on the bottom, it's 0 minus 8. So we have -10 over -8. Negative divided by a negative is always a positive, and this one can reduce to be 5 over 4. Opposite reciprocal of this, so we're going to flip it, 4 over 5, and we're going to negate it, so it's going to be -4 over 5. So the perpendicular slope equals -4 over 5. This goes through vertex B. Vertex B has an x-coordinate of 5, a y-coordinate of -10. Let's plug in the pieces, point-slope form. Y minus y1 equals m, -4/5, times x minus x1. Let's distribute. Y plus 10 equals negative 4 fifths x. Negative times a negative is going to be positive, so this is going to be 20 over 5. This is going to end up being 4. Oh, that makes sense, because we have 5 in the denominator, 5 in the numerator, so it's going to be x plus 4. Cool. Let's subtract 10 from both sides. Y equals negative 4 fifths x minus 6. 2 equations down, 1 to go. Slope of AB. This time we don't get to use the zeros. So it's going to be negative 10 minus 10. And then I'm going to do 5 minus 8. Negative 10 minus 10 is negative 20. 5 minus 8 is negative 3. Negative divided by negative, positive, so it's going to be 20 over 3. It's kind of an annoying slope, but it'll work for us. Of course, the opposite reciprocal will be negative 3 over 20. So the perpendicular slope is negative 3 over 20. This one needs to go through vertex C. Vertex C is at the origin. So our x sub 1 is 0. Our y sub 1 is also 0. Let's plug in the pieces. Let's just see what happens. Y minus 0 equals negative 3 over 20 times x minus 0. Simplifying here, this left side turns into y. The right-hand side distributing the negative 3 over 20. Times x is this, times 0 just is nothing. Here we go, 3 equations. This one we are going to actually have to set some stuff equal to each other to figure out what our x's and y's are. So I'm going to pause this thing and reorganize, but I'm going to use these 3 equations as we move forward. Okay, here we are. We have our 3 equations. I haven't done anything to them. I just relocated them. Now, at this point in time, we know that this y, this y, and this y, they're all going to be the same exact y. We're forcing that to be the case because we want to know where these 3 lines intersect. There's going to be a single point where they intersect. And then the 3 x's, we're trying to find the x that makes all of these true as well. So our move here is we need to pick 2 of them, set the right-hand sides equal to each other, solve for x, and then go back and substitute that other piece in. Lots of correct ways we can proceed. We just need to pick 2 of these. I really don't know what's going to be the easiest route to take. My gut tells me to stick with the 2's here, so I'm going to go with this one with a denominator of 2. This one has a denominator of 20. It might be the easiest, it might not. I don't know. There's different correct ways to do it. This is the way that I'm going to do it. So I'm going to set 1/2 x plus 6, which is just the right-hand side of this. This has a value of y, according to our equation. I'm going to set that equal to negative 3 over 20x, which also has a value of y according to this equation. So essentially, we're just saying y equals y, but in this form, these 2 expressions have the value of y. So we can manipulate this thing, solve for x. That's our game plan right now. So I want to get rid of these fractions. I see a really big fraction here of 20. So I'm going to make a bold move. I'm going to multiply everything up here by 20. I'm going to multiply the left by 20, multiply the right by 20. And what this is going to do, although the numbers are about to get a little bit bigger, it's going to remove every fraction from here, because this is also a factor of 20, and then this 20, of course, is going to go away. So 20 times 1/2, or 1/2 x, if I have half of an x and I have that 20 times, that's going to turn into 10 x's, plus 20 times 6, that's a constant of 120. Okay, not so bad. On the other side, a few different ways we can look at this. We can notice 20 is the same as 20 over 1. We can say that these 20s cancel out and you end up with negative 3 over 1. That's one correct way to approach that. You can also say that negative 3 times 20 in the numerator is negative 60. Negative 60 divided by 20 times 1 is also negative 3. So either way you look at it, this is going to be negative 3x. Okay, let's subtract 10x from both sides. It's going to be negative, but we'll gather everything over there. So 120 equals negative 13x. I don't know what 120 divided by negative 13 is. Grabbing my calculator, 120 divided by negative 13 and I got a gross decimal. X equals negative 9.23. Okay, full disclosure, this one's making me nervous. That's not what's in the answer key, but I feel pretty good about the work we've done. So let's keep pressing forward and we can verify our answers here in a bit. It's going to be annoying because of the decimals, but hey, I think we're up for it. So our claim here is that our orthocenter has an x coordinate at negative 9.23. So we're going to take this now, we're going to plug it into any of these three equations. To be extra safe, I think our move should be plug it into the one that we didn't use already. So that one is the y equals negative 4/5 x minus 6. So it's y equals negative 4/5 times this value, negative 9.23. We'll definitely use a calculator for this, minus 6. And we'll see what y equals. So what I'm typing into my calculator right now is I'm typing in a negative 4/5, negative 4 divided by 5. Of course, that's negative 0.8. And I'm going to multiply that by negative 9.23. So times negative 9.23. I got 7.384. I'm going to subtract 6 now. And I learned that y equals 1.38. So our claim here is that y is at 1.38. Okay, what I'd like to do now, just to verify things, is to check our answer. I'm going to plug these two values into, we know that it works in this equation. It's probably the hardest one. We're going to plug it into the other two equations and just plug the numbers into our calculator and see what happens. I'm going to clear some space here. This y value is already recorded, so we're going to utilize that up there. So I'm going to take this next equation, take the top one, because we haven't used that yet. Y equals 1/2 x plus 6, and I'm going to plug this value in for x, this value in for y, and my hope is that the left side equals the right side. So 1.38, we are saying equals 1/2 of negative 9.23 plus 6. So let's type the stuff in that we see over here. 1 divided by 2 equals, of course, 0.5 times negative 9.23 equals, and then plus 6. And my calculator says 1.38. Awesome. So this one works. I just plugged this in my calculator, and that is indeed the result I got. Just to be extra safe, let's do the other one as well. Y equals negative 3/20 x, subbing our values in, 1.38 equals negative 3/20 times negative 9.23. Again, this is an exercise in using the calculator. Negative 3 divided by 20 equals, and then I'm going to multiply that by negative 9.23. I hope when I click enter, it says 1.38. It does say 1.38. So this is indeed the correct answer. This is our orthocenter, and I have just learned that my answer key is incorrect. So we've gone through, this is how to do number 18, and we've even checked our answer pretty robustly. So do what you need with these videos. Hopefully they help. Let me know if you have more questions.